Jain student, my name is Pradeep and I am working as an assistant professor in IT department in Ajay Kumar Garg Engineering College, Ghaziabad. Today we will discuss the subject is Basics of Database Management System and the subject code is KOE067. So let's start the topic. Today's topic is functional dependency. In short, we write these functional dependencies as FD. So just remember, FD stands for functional dependency in many books, and this functional dependency is written in short, so don't be confused. It means functional dependency. So let's start. What is functional dependency? So a functional dependency is a relationship. It is a relationship between two set of attribute in a relation from a database. So what it means, suppose there is one database. So database is basically a set of relation, or you can say set of table. So there are various relation are available. So R1, R2, R3 or R4. So let's take one particular relation R1. So in R1 there are various attributes. Okay, suppose the scheme of relation R1 is A, B, C, D, E. Okay, so let's suppose through ABC we can find out C, D, E. Okay, so this is the functional dependency. This thing is known as functional dependency, or in short I can write FD. Okay, so a functional dependency is a relationship between two set of attributes. So there are set of attributes, okay, in a relation. So R1 is a relation from a database. So R1 is from a database. Okay, so from this set of attributes we find some set of attributes. So there is some relation between this set of attributes. Now let's see the next point. An attribute or set of attribute X is said to be functionally determine another attribute Y written as X derived Y or X determined Y if and only if each X value is associated at most one Y value. So what it means, so suppose there is attribute X which determine some attribute Y. So here X is the determinant. X is the determinant, okay, and Y is the dependent. Y is the dependent. So X determine Y, and each X is associated with at most one Y. Okay, so each X is related with at most one value of Y, with at most one value of Y. It is not something like that corresponding to one X there are more than one Y. What it mean, so I can write here. So suppose X determine some y1, x determine some y2. This should not be allowed. This is not allowed. So there is only one y corresponding to one x. So let's see why functional dependencies are important. So functional dependency helps in designing database in relational model, in normalization and in denormalization. So it helps in designing relational database model, it helps in normalization, and it helps in denormalization. Okay, the functional dependency along with attribute domain are selected so as to generate constraint that would exclude as much data as inappropriate to the user domain from system as possible. So it exclude inappropriate data. Okay, it exclude the inappropriate data. So this is important. It exclude the inappropriate data. Okay, it exclude the inappropriate data. Next, the type of functional dependency. So at broad level, functional dependencies are categorized in three main categories. One is trivial functional dependency, second one is non-trivial functional dependency, third one is completely non-trivial functional dependency. Let's see one by one. So let's consider the functional dependency. A determine the dependent B. So A is some set of attribute, B also may be some set of attribute. Okay, so what is the meaning of trivial? Okay, so suppose if B are subset of A, if B's are subset of A, then it is known as trivial functional dependency. What it means? Suppose we have B set and this B set contains the set of attribute, suppose x, y, z. Okay, and okay, sorry, let's erase this one. Suppose these are subset of A. Suppose there is one subset A, one set A, and this set contains the attribute, suppose W, X, Y, and Z. Okay, and A determine B. Okay, and B are subset of A, suppose Y and Z. If situation is like that, then this is trivial functional dependency. So what it means? So if we know the value of W, X, Y, Z, so W, Y and Z is already included. Okay, so this can be determined trivially. So this is trivial functional dependency. Next is the non-trivial functional dependency. So if at least one of the B's is not among the A's, so what it means? So this is the trivial functional dependency. Now let's take the example of non-trivial functional dependency. So there is A which contains some set of B and B which contains some set of B, set of attributes. So suppose A contains some set of attribute, suppose W, X, Y, and Z. So these set of attribute determine the set of attribute, suppose V, X, Y, and Z. Okay, so there is Non-trivial means if at least one of the B's is not among the A. So here V is present, this is not present in A, this is not present in A. Okay, so there is at least one B's which is not among A. So this is non-trivial functional dependency. Next, see the completely non-trivial functional dependency. If none of the B's is also one of the A's. If none of the B's is also one of the A. What it means? So let's take one example. Completely non-trivial functional dependency. Suppose A determine B. Okay, and in A there are some set of attribute. Suppose A, B and C, these A, B, C functionally determine the set of attribute of B, suppose X, Y and Z. Okay, so there is nothing common in between A and this A set of attribute and this B set of attribute. There is nothing common. Okay, there is nothing common. So these are completely non-trivial functional dependencies. Right? So if I can write in terms of set theory, then I can write like that. So suppose okay, so suppose if I have in trivial functional dependency in terms of set, if I can write, if there is A some set of attribute and there is B, if we take the intersection of these two, then it is B only. Okay, so B's are subset of A. So in non-trivial functional dependency, if we take intersection of A intersection B, then it is not null. So this is the symbol of null, so it is not null. Okay, there is some attribute. If we consider non-trivial functional dependency, then also A intersection B, okay, this is also not null. Okay, in non-trivial there is at least one attribute which may be common, so this is also not null. And okay, sorry, if we take intersection of these, then it is equal to null. Means there is some set of attribute in A, suppose A, B, C, okay, and there is some set of attribute in B, suppose X, Y and Z. If we take the intersection of these two attributes, then it will be null. So this is the meaning of this completely non-trivial functional dependency. Next, see some real example. So in trivial functional dependency, suppose name and roll number determine the roll number. If we know the name and roll number, then we can determine roll number trivially. Next, see the non-trivial functional dependency. So suppose we have name and roll number. From these name and roll number, I can identify roll number. Apart from roll number, I can also identify section, branch and section. So these are not included on the determiner side. So it is non-trivial functional dependency, but there is something common. So if we verify that A intersection B then it is B itself. If we take A intersection B, then it is not null. There is some value, means roll number. Now completely non-trivial. So suppose we know the name and roll number, then we can identify age, branch and address. So if we take the intersection of A intersection B, then there is nothing common, then it is 5. Next, see the functional dependency rule 1, and the rule 1 is reflexibility or trivial functional dependency. So it is something like trivial functional dependency. If B is subset of A, then A functionally determine B. Means there is subset of, there is set A and B is subset of B. Okay, B is subset of A, then this is reflexibility or trivial functional dependency. So suppose we know name and location, then we can identify name. Next, see the augmentation. If B is subset of A and C functionally determine D, then A and C functionally determine B and D. Okay, so what it means? So suppose we know the name and location, then we can identify name. Okay. Next, if we know the birth date and time, then we can identify age. Then from name, so suppose this is attribute 1, attribute 2, attribute 3 and attribute 4. If we combine these 4 attributes, this is attribute 1, 2, 3 and 4. With the help of these 4 attributes, I can identify or determine, suppose this attribute 5 and 6, we can identify the attribute 5 and 6. Okay, fine. So this is augmentation, means we combine this, you can say functional dependency. So in terms of FT, I can write A, if A determine B, if A determine B, okay, and C determine D, okay, then A and C can functionally determine B and D. Okay, fine. Next, see the functional dependency property inference rule 2, transitivity. So if A functionally determine B and B functionally determine C, then A functionally determine C. So what it means? So if A functionally determine B, okay, and B functionally determine C, then from these two FDs I can infer that A functionally determine C, because through A I can determine B and from B I can determine C. So this is transitivity. This is transitivity. So let's take one example. Suppose from Aadhaar card I can identify PAN ID, from Aadhaar card I can identify PAN card, and from PAN card I can identify age. So that's why from Aadhaar card I can identify age, because from Aadhaar card I can identify PAN card, and from PAN card I can identify age. So that's why from Aadhaar card I can identify PAN card, and indirectly or transitively I can identify age from the Aadhaar card. So next is the pseudo transitivity. If A functionally determine B and B and C functionally determines D, and A and C functionally determine D. So let's take one example. So suppose from roll number I can identify branch, and from branch and section I can identify class counselor. Then from roll number and section I can identify the class counselor, because from roll number I can identify the branch. Okay, so implicitly this branch is included in roll number itself. Okay, so to identify class counselor I need section, so section is present, and we require branch, but branch is available through roll number, because from roll number I can identify branch. So this is pseudo transitivity. Next, see the union. If A functionally determine B and A functionally determine C, then A functionally determine B and C. So what it means, if A functionally determine B and A also functionally determine C, then from these two FDs I can derive that A functionally determine B and C. Okay, so from roll number if I identify student name, and from roll number if I identify branch, then from roll number I can identify student name and branch both. Next is the decomposition. If A functionally determine B and C, then A is functionally determine B and A is functionally determine C. So what it means, suppose if A functionally determines B and C, then I can decompose these functional dependency, and I can write as that A individually can identify B and A can identify C. So this is decomposition. So from roll number if I can identify student name and branch both, then from roll number I can identify student name, and from roll number I can identify branch. Thank you. Jai Hind.